All right, welcome back to PS, and today we're going to continue working on our regular expression library. So last time we left off realizing that um, that C++ doesn't necessarily come with the UTF-8 support that we wanted, right? We want to make sure that you can create regular expressions in any language, essentially. But the reason C++ isn't necessarily good is because, for example, with strings, the string is essentially it's an array of characters. Each character is 1 byte, according to the C standard, and 1 byte. And UTF-8 characters can be multi-bytes. So, for example, if you had some kind of string S and it was called hello, and then you did a plus equal a character 8. That works fine with ASCII. That doesn't work fine with UTF-8 because UTF-8 can represent ASCII, but it can also represent characters using up to 4 bytes. So we're gonna before we dive into RE3, I think it's worth looking into writing a UTF-8 library and then using that UTF-8 library to build RE3. I'm actually also going to make this a separate one, just because a separate project, just so we can include it, and it'll modularize our code and make project management a bit easier. Yeah, so we can table RE3 for now because we're just working on this requirement. And I have a bunch of stuff about UTF-8 up. This is a bunch of test data for you. Hold on with this. Yeah, so this explains how we could use a thing called wchar-t, which is a wide character, to work with UTF-8. Yeah, that is. All right, so we're going to set things up. All right, developer. Let's see. What do you tell? There. UTF-8 string. UTF-8 string. All right. Get some stuff out. Okay. Okay. Great. Okay. So we're gonna make UTF-8. Right. UTF-8. We'll also make this make it a C, or we'll just use a file instead. Okay. So let's just get our ideas down like a note-style text. You'll notice my setup is a bit different. I'm experimenting. I have a thing called Tmax, which will open terminal Emacs in a new window. I just like it a little bit better. All right. Notes. Okay, so we want to make UTF-8 string library. So first, let's ask ourselves, what is a normal string interface for C++? And then we want to replicate that with UTF-8 support underneath. String interface. Oh, wait a second. This U32 string. Interesting. We use this to our advantage. Char 32. Okay, so if we're making UTF-32, we could use this. And then we just have to re-implement how we add characters. string. This is the wide string. Types, functions, string library. These are some of the methods. So obviously we have the constructor. What do people do? They index back. We have accessors, like index-based access, at, in, or front and back instead. And base, we want to get a C string because that's useful. What else do they? We want to test if it's empty. We're not going to use iterators. Iterators, I think, were added for better algorithmic support with the standard library, but we won't be implementing that. This is just a UTF-8 library for ourselves. And if you're wondering why are we implementing our own library instead of just using some other utility someone else uses it or someone else made, we could do that, but that's not as interesting. I think writing our own would be more of a learning experience, which is what this channel is mainly for. It's for learning and having fun while doing it, right? So they have a find. Should we implement that? We add our own utility for it, but I don't know if embedding an algorithm thing inside is that smart. Let's see, what would be the use case for this? Let's see what this is. Find first of. It'll return the index where it found it. We want to use. It's unspecified. We might as well just implement it outside. I don't think we need to implement that inside. Okay, so we also want to have methods for editing the string. Right? So we want to append at the end. We want to replace a character. But that'll probably work with the index too. Or we can have two versions. Index read only, and then we can also index with write permission for a character. What else can we do? Oh, we would want the length for one of the. If we want to know if it's empty, we want the length. We could get the size in bytes. C string. Is that intelligible to say that if it's a UTF-8 string? Because not everything will get represented as a string. Just leave it for now, but then we'll add a warning here. Not all chars can be passed to UTF-8. So here, what else would we want? We have a pushback, popback. I guess we could add those two. Pushback. That's a pushback and pop. Pushback and append, I think, do the same thing. Index will do that. Oh, I guess we could have a replacing for a range. So some kind of range-based replacement. Oh, they call it replace. So we have replace. This will be an overload set because we can provide a bunch of interfaces to do that. If we're doing append, it's not. Let's call it. Let's just call it pop instead of pushback and popback because it makes it sound too much like a vector. We can access a substring. Right? Okay. Right. So that's what we have. Structure destructor. Copy, compare. This is compare. Oh, okay, so you can compare it to another string or substring or a bunch of other. Not that. I guess if we need it, we can add that later. But right now, the meat of it is how we represent the array underneath. Right. So we'll probably what we'll do. Right. So UTF-8 is different from ASCII, right? ASCII was written pretty early, and it represents each an integer, 7 bits, can represent up to 128 characters or something like that, right? So it mainly represents English and like a bunch of other stuff. So English and symbols, right? So with UTF-8, it uses up to 4 bytes. So UTF-8 is 4 bytes, 32 bits. Okay, so I guess we should have the ability to construct by default an 8-bit one. Okay, so instead of calling it a UTF-8 library, let's just call it a UTF String library. By default 8, but you should be able to construct up to 16 and 32-bit strings. So what I mean by this is each so the entire string can be represented by a 32 or 4-byte integer or a 4-byte array. So here it's 4 bytes, and so if you just wanted so UTF-8 is backwards compatible to ASCII. Oh, I guess we could have because it's backwards compatible to ASCII. We should incorporate that in our interface somehow. Yeah, which is incorporate or make it rather explicit that it's backward compatible. So explicit, right? So it's a 4-byte, and then if you just use 1 byte, so you can use the first bit of ASCII or a UTF-8 string to determine how many bytes the rest of the string is. So, for example, if you're writing just an ASCII value as UTF or encoding it as UTF-8, it will be 0. The first bit will always be a 0, and then it will be 7 other things. Right? And then these 7 bits actually encode the ASCII values. And then after that, I believe you can, if you represent something with 2 bytes, so that's UTF like 16, it will be, actually I don't remember off the top of my head what it would be. This is a good test. We can get this later. I guess. Yeah, so C char is 8-bit, which is 1 byte. So we can just look up, I think the UTF-8 Wikipedia explain what I'm trying to get across. Yeah, so here 7 bits gets represented by that. Right, this is why it's backwards compatible with ASCII, which is super cool. If you have 2 bytes, you can represent. Okay, so you get 11 bits to represent whatever character set you want, which can be the 2048. And then I believe in 2003 they put a restriction on the number of bits you can have to encode a character. I don't really know why, but it's the thing they did. And then with this I think you can do up to 21, right? That can represent. Oh, that's what this. Yeah, that mentions that. That can do 2 million. Is that right? I thought it was like 1 million. Oh yeah. Oh, okay. So it's doing that and more. Okay. So you can represent up to represent a lot of characters. Super cool. Super important. So here, if it's a 2-byte, you got 11 bits. 1 byte. 7 bits to represent the alphabet. And with 2 bytes, you got 11 bits to represent alphabet. So it would be 110, and then 2, 3, 4, 5, 1, 0, 1, 2, 3, 4, 5, 6. If you represent it with 3 bytes, you get 16 bits to represent it. So you can use the first few bytes to determine how many more. You can use the first few bits of the first byte to determine how many bits were used to represent a certain character. And that's why appending a character here is rather complicated, right? Like if you had each character can be up to 4 bytes, but obviously some of them don't necessarily need 4 bytes, right? A single ASCII char would only need this first byte. So appending a string using C++ would append here, right? But you could have characters that take up 1, 2, 3 bytes, or up to 4 bytes. So you can't just append a character, which is what makes UTF-8 powerful but different. Here, right. So what we can do, how that makes this library different from string. So underneath, I think the underlying data structure should still be some kind of like array of chars. Can we do that? No, it should be a bit array, I think. A bit array. Here, and then when you append a character, we get the bits and we append the bits rather than just getting the character representation. What would that mean though? Okay, so a string would it would be an array for sure, but it wouldn't. I guess it would be of a UTF-8 char or UTF char, which can be up to 4 bytes. And then this UTF-8 char, UTF-8 char would just be a bit array, right? And then if it's an 8-bit, 8 would be 1. It would be, so I guess depending on the constructor, you can allocate different amounts to this array. Change between constructors. And then every time you append or index something, you're indexing a UTF char. I guess that's what a wide character is, right? If we look at this wide character library, see wide strings. See if there's like a. Okay, this is like a wide. We're looking for a wide character, right? Let's see the size of this. Compiler. Oh, it's not portable. Fun. Alright. Traditional is greater than 8-bit. Okay. Good. Okay, so you can actually choose how wide the character is. So normally it'll be 8, then you can get up to 1632. So we don't have to actually define like our own UTF char. This can be an array of char t. So here it can be a char 16t or char 32, depending on what you need. Because char by itself is already 8 bits. This is 16 bits. This is 32 bits, and then we can use those to represent things. 4 byte. That's cool. Let's see. demonstration of their use. So let's look at a chart. Count. Nice, yeah. Okay. So this 3-bit would probably just get represented with 32. So we can do char for this. We can do char 16 T for this. Probably, and then this should be char 32T. And then the last one, which will also be char 32T. And then you'll have 4 bits to represent that. 6 bits to represent that. 6 to represent that. So the first byte determines the size of the remainder of it, and that's actually a security feature. So if you see a string that claims to be really, or a character that claims to be really long, but actually isn't, you can get suspicious of it, actually, or the converse. So this would be 4 ones. Okay. And use 3 bits, and then the remainder. Okay. So that. Here's that. We can have an array, certain type, depending on how they construct it. And then we have to define how they can append to it. Okay. I guess we can also just store the size of it. And then we can use, so the size will be different though, right? Size, normally you could just check the number of bytes. That's not exactly the case. UTF 8. Okay. This is good testing. This. Okay. Symbols, Punjabi. Oh. Titus is testing Unicode script management. Oh, I guess this is in. Okay. The wide characters will be used, but we want to have explicit control over this. Okay. So this would probably be a little bit of infrastructure setup so that we can actually test our libraries or running it. Right, so we have our notes. Let's use a make file for this. I can change it to CMake depending on what people want. Let's actually just use CMake. I think and then we'll keep it a little bit simplified. Right, so we want to. I never really remember how to use a CMake. It's super complicated, so I'm just going to go to a previous project I ran and just replicate that. My GitHub wrote a library before called Condit, which is a type essentially. We'll just replicate this because it works, honestly. And hopefully, if you're watching and you have a different operating system, you can, once I push this, hopefully you'll be able to use it as well. Set it to UTF String this time. Right? We want to set it to a C++ project. Position independent code. Right. Oh. So we won't have a subdirectory, but we do want to declare. So we can make this this will be a relatively small library. We can just add it here. We can add a library. We want to call it not lib status because I think it will call it lib status. When it compiles it, but we can call it UTF str. We'll make it we won't make it a static library. We'll make it shared so that. And the difference between static and shared, if you don't know, is if it's static and you compile a binary, it'll copy all the object code for this library into your binary or whatever object code it needs. It'll compile it all together all at once. But with a shared library, also called a dynamic library, it will dynamically load an object file in during runtime when it needs to. The difference is static libraries are larger and generally, I think, faster and less prone to break because you have your code already compiled in. But with a shared library, you run the risk that the computer that's running it won't have the object file you need, but it'll make your binary more lightweight. We'll have call it UTF String.cc for now, and then we want to add an executable for a test. Yep, tests here. Get a test folder. Have these tests. Let's see if that's useful. Look at this. Definition generator. Not define loss. Not of additional. Test. Test driver program. Okay, so we'll just work. Do we need this? I don't think I think we can just use the. Pretty sure we can just use the certs. Sure, it works. We added this. It'll create a target called make test. And I don't really know if we. And whatever, we don't need it. We're gonna just use. We'll just declare it as an execute. UTF string test. String test.cc. This will have a header file. And we want to add. We want to do some linking, right? I'm going to do target link libraries. UTF string test. Public. Add. Let UTF string. And this creates an executable. Yeah, I think that's okay. So let's create those files and see if whether we can just compile it real. And then I can add other compiler flags as we need them. So you have string. Let's actually So you will call it UTF String.h. So we'll do our header guard. String h. So when I write C++, I tend to follow just the Google style guide. It was an arbitrary choice. So we'll just have a test method, so print hello. Right. And we'll have a UTF string.cc include header file, which is UTF string.h. Hello, we're defining the function that we wrote. I'm just going to print out hello. Okay. Let's actually go back to our CMake list to see what our UTF string underscore test is. String underscore test.cc. We call things CC. Okay. We'll just create our header and just run it in it. We'll do UTF string.h. Test hello. And this will just be a method that runs print hello. Okay. Runner. Okay, let's see if that worked. Right. Okay. Plus. Alright, that looks good. So we're going to create a build directory. Let's see, maybe the previous one. I'll specify link libraries for target. Not built by the. Oh, I guess we gotta add the executable before we. So we'll go back to CMake. It's the same. So we add the executable first, and then we link the library. I think it's complaining about. Okay. Let's try that again. Build. Okay. Here we have. Just gonna call make now. Great, made the UTF string wire. There we go. We can run it. Hello, great. Okay, so we got that set up. Now we can actually get to actually writing the thing. So text editor, string.h, right? Get rid of that. So we'll call it UTF string. Right? Right interface. We want them to be able to determine the size of the character they're encoding into their string. So we can have a constructor. We can have the constructor take an argument for that. That's good enough. So we can have them allocate the byte size. We can also have them reserve a certain size for it. So this is a constructor, string. We'll have a default constructor because easier. We'll have a custom constructor. It's a standard size key. Instead of having them give us a number because they can just pass in something that's not 8, 16, or 32. We'll have a struct or an enum and have them pass us a member of that enum rather. So we'll have an enum class, char size. Okay, yeah, I think that's okay. And then we can specify 8 at 16. Or we'll have them give us a byte number and we'll make it more. So let's look up class declarations because I'm not sure if there should be semicolons. Pretty sure, yeah, it's pretty sure it's just supposed to be commas. So we can just do, yeah, I guess my Emacs is just acting up 4. Right? Alright, char size is 1, 2, or 4, so that they can give us that, and then we can say, give us the char size. That will be one constructor. We can have them reserve a certain amount. Have a size t, initial capacity, and we'll have both too. So we'll have a capacity and a char size for that capacity. And then depending on what they give us, we'll construct a different string for each. Does that work? We just do that? So if they gave us a 4, maybe we have to use like a factory method for that. That's not okay. By a factory method I mean instead of making these like public constructors. No, let's not do that. Most people expect to be able to just like construct a string pretty easily. If they give us a 2, for instance, we would have to set our array to be a chart in T array, and then if they gave us a 4, it'd be chart 32 T array. But using the constructor to do that. Not that. Could I have a void pointer instead? I'm pretty sure a void pointer casts to anything. And then what we can do is we can set that void pointer to point to a 32-bit array or an array of 32-bit characters. And we can change where that pointer is depending on the type, and then them copying stuff like that in between. Pretty sure void pointers point to anything, right? Let's check that void pointer. Void. Any other pointer type without an explicit cast. Okay. Do we do that? Safe. But I guess we're controlling the interface, so it should be safe. No. No, it's a function that can receive a pointer and store. Has to. Yeah. Really look up, see if someone else has experienced constructor argument affects affects a class member. Yeah, I don't want to use inheritance for this that big. I guess we could do that and then just remember what char size they gave us. Private void array actual string. We'll maintain a size. Then we'll remember the char size itself. Okay. So this is just a set of constructors. We want either constructors, we want to be able to copy a string from another. So we want to construct a string, but instead of just from itself, it's from UTF string reference other. We want people to assign it. String. We'll have an equal operator, right? Gotta remember that. Okay, so that's what then equals, and then it will be a const string as other, right? Would we need a character? We don't have. Oh, we probably would, because this void, this could contain malloc data, so we'll have string. We only need a single one. Right. Now, what other methods do we want? So here we'll look at our notes. Right, so those are destructors. Now we want to have an index, right? So we'll have pointer to a char, void pointer. How do we return? This type actually changes depending on. Oh, I guess we could make this a templated class instead. That way, literally change what we can construct something like a UTF string and then pass in the type as like char 16 underscore t, char 32 underscore t. But the danger with that is they can just pass like an int. That's not that good. So what can we? So at should return a character, but what should we return? I guess we should just return a 32 because that's always the size limit, right? A UTF-8 character will never be larger than a 32. Yeah, let's just do that for now. We'll do a char 32t. Let's see what we need to include for that. Okay, so I guess we. Again. Okay, so we need to add to our CMakes list to ensure that we have at least because that's the only type that includes char32. So, okay, their file. Oh, that's an unsigned. The wide character? Wide character, right? So we want to include that at the top. Char.h. And here we'll add to our CMake required minimum version. We can just set our CMake syntax standard B11. Right. And we probably want different flags depending on if it's debug versus main production build. We can worry about that later. So wchar will always. So let's go back here. We'll always return this, and then we'll do at, and then we can specify an index. What else we wanted? Index. So and then we'll have at do array. It'll do size checking so that you don't index out of it. But we'll have the operator here not do that. So we'll have a char32t as well. We'll have it return a copy. I don't think we need a pointer to a single character. Operator equals, and we'll take a standard size t index. So if you happen to wonder, why am I writing all the interfaces? None of this will get implemented. You should be doing it one at a time, because we'll actually just comment out a whole portion that we actually don't need, and then we'll change it as we go. This is just so we can predict any kind of dependency that we need in it. And it can help us reason about our API and make sure that we're on the right track. So we'll have a char32t as well for front. All right, and none of these should be changing. Oh, we'll have at be const, but this will be different. We want someone. Oh, it's not equal. It's this. We want someone to be able to replace a character, and also to get a character. So this would be there's two versions. One would be a reference to the character, and the other would be the const version. So we can just have this be const, and then we'll also define an interface to return a reference, and then we'll have that later. So we'll do 32t back const t string, so we can return a const char array, right? Pointer to it. C_string. This is a pointer to a character that is const. Will that make sense? Probably not. Warning. Doesn't make sense. Come back to that. So we want to get size. So this should be a size t. Yeah, it should be a size t. Then we can call it size. Then we have empty, so this would be a bool. This can just be a check size equals 0. So length versus size. Length will be size will be the number of bytes used up total, and then length will be the number of characters it has. We'll this size t as well. here. That's what we're gonna do. Empty length. We also want to. Oh, we want to access substring. So this should actually return a UTF string. It probably won't return a. So there's a concept that got introduced in C++ 17, which is the concept of a string view. So instead of returning, so normally when you have like a method that returns a string, if you don't actually manipulate the original string, so for example, say you're getting like a substring of this large string, normally what people will do is they'll make a copy of that string. But an optimization in the form of a type came with string view, which is like a view into a portion of the string. And I don't know if we'll implement that here. We'll see. But that's definitely an idea we can explore. I'll just add that in here. We'll have explore string view. Because right now our substring will not return a string view, it will return the actual substring. And then how will we specify? I guess we could specify two indices. We specify a start and an end index. We can also specify a start and then an offset, so it can be a number of characters from this starting point. We can just do both. Just do that. So we'll do standard size t, start index, and then size t offset. And we'll have another one. Size t, start index, and standard size t, end index. Right. So we have them able to specify their character size. We also have default values for 1, 2. Right. So get this out of the way. We got a destructor. We got all this. Right. Good. Now we're gonna add interface for editing it. Here we want to add append. Right. So this should be void. Or what we can do is, the void isn't that useful, but we can actually return something useful that they can check optionally. Right? Can we do that? And because it's also possible that they have a compiler flag to use all unused, to use all values, right? That's just to make sure it got wasted. Yeah, both versions, I guess. We'll have append just to append another string to it. Oh, we also. Oh, I just realized we want this to work with standard string too. Because that's totally the case. We want to be able to take a normal C string or C++ string, take it, convert it into our string, and then vice versa. That's super important. Well, I guess I can go here or in a different library. No, let's actually just add it here. So we can construct a UTF string from another string from a standard string reference other. We should also be able to construct it from a C string. Let's char pointer C string. That. Okay. Okay. We can have it from there. So out, and then we'll have methods to convert it into the string or standard. I have to include, I believe, string.h will include wchar.h. I hope. Oh, cool! There's an entire wiki book. We'll keep that open and have that. Uh, Probably not. So we'll just include those. Oh, wide characters define also. Dude, string.h. Well, actually, just in standard def.h. We want to also include this. And we're not using any methods here, so we can just get rid of that. And we want to do string, the C++ string library. The way this compiles. And now we want to return. Well, we already have it returning a C string. Because we could have it. We could have a toString method below. Here, sense string toString. To C string, and then we'll call this toString. Place that here. And then so toString. All right, yeah, so now we'll work on these. So we want to append UTF string here. String other. We have the other. Okay, because this is the same class, we can access the character size and then determine how to properly add them together. We can also have int append with size, maybe. Actually, we'll just add that as a to-do. I don't know if that's like a good choice. So here, what else do we want to add? We want to do index, but instead of just the char32 t, oh, we can't just do this. Because if they encode it as a separate type, if, for example, if they just do a char, or if they do 16, I don't know if the pointer type will easily match. Huh. So we could do a void pointer for now, I guess. And then that'll give us a pointer to. Actually, we don't have to get the character back. We could just do it this. And we could do. What do we do? So our accessor get this and then. So. Oh, so our type would be bit. I guess we'll worry about that later. Our replace method. So let's add it to do. A reference to replace. So now we'll have a replace method. Replace, and then we can replace a certain. Let's actually just look at the C interface for this. This is what people will be used to anyways. String library here, wide string, wait string. I already had these. Oh, C++20. Oh, and they also have string view. Look at this. What is this? A lot more complicated than here. Because there's an actual group of people that write stuff. A lot of people. I guess that's what happens when you keep writing software more complicated. We're looking at the replace interface. Oh, we also have to add capacity. Replace. We can do standard size t index, and then the UTF string. UTF string reference to replace it. We should probably have the same interface for other kinds of types. Placement. Place t index. Placement. And optionally, this should also come with this size. T size. Okay, and the same thing here, right? Same idea. This is what's called an overload set, pretty sure, which is the fundamental unit of an API, which is an API isn't a set of functions, it's a set of overload sets, and each an overload set is one function that gets overloaded by a bunch of other functions, and the compiler does the job of using the right function, but the programmer doesn't need to know about the interface. So for append, we also want to be able to append string to this. Right, and then we wanted to do pop. So append will add a string. Pushback will also, so append and pushback should do the same thing essentially. We'll do pop. Pop. And that should just get rid of the last character. Now we also, this is something I forgot before, but we have to probably add some memory management stuff to this, right? So we want people to be able to control like the buffer size when we in our void point. So let's so size will tell us number of bytes. Capacity will be the size of the array underneath. We can ask them to access the capacity and also to change it with a method called reserve, which is why we gave them a size feed this constructor. So we want them to access it. It's an accessor, so length, and then we will return a capacity. And then so UTF-8. This is that. We'll move this up. This is here. Right. And here we'll give them the ability to reserve a certain capacity, which is what our constructor will call. Okay. Size. Right. And pop will just get rid of the last character, or last like byte character. Okay, great. So that's essentially our interface. Here. And we have them currently giving us a character size, and then from there we can give them a clean way of adding and maintaining a UTF compliant string. Yeah. All right. So I think that'll be it for tonight. I haven't been doing well with sleep, so I kind of want to make sure to get enough sleep. So yeah. So for tomorrow, what we'll do is we'll comment out a whole portion of this, and we'll probably start working on the constructor tomorrow. yeah, probably by tomorrow we can probably get the constructor and maybe some of the a constructor and destructor in for sure, and then maybe we can get to our copy. And then tomorrow, hopefully, I'll look a little bit into move semantics too. So that this API might change tomorrow as well. Right. Great. I'll see you all tomorrow then.